Okay, hello everyone. Yet another video from Pathfinder Tuition. So I'm Mr. Leon here again. Okay, today's video we're going to talk about a very commonly misunderstood topic. Yet it is something that we see in our daily life a lot, and the topic is called heat and temperature. So this topic might be something that you have learned since the beginning of science, right? Whether you have learned science already in a PhD student, as a PhD student, or you have not learned science before, but definitely you have seen all these things happening in your daily life before. But of course, the question is always, do we necessarily know how to tell the difference and how to explain in a more scientific manner? Okay, so look at this, the screen now, you can see that there's actually an iron. Okay, this iron is commonly what we use to straighten our clothes, although this is pretty traditional because in today's context, actually we use the steam one, where we just run up and down on the clothes itself, and then there's no need to find iron board, and then after that you start ironing it. But this is something that comes to my mind when we talk about heat. Why is that so? Because this iron is really very hot. Okay, so that's the word that you use. So often in the real life we talk about this thing called that's being hot. So hot, it means to say that, right, it is something that is of, okay, I would say high temperature. And of course, temperature is also a word that we should not be unfamiliar with, because we measure our body temperature every time when we want to see if we got a fever or something like that. So high temperature will be something that you think of. So hot means high temperature. But of course, what exactly tells us that this is hot? Okay, what exactly tells us this is hot? You don't necessarily need to have a thermometer. There's many telltale signs to tell you that this thing is hot. Like one of the things is, there's steam coming out from the iron. And of course, your recollection of things will be right. You remember that iron could be very hot, so I got to be careful, so on and so forth, right? So, and of course, last but not least, if you're so unfortunate you didn't know, when you were younger, you didn't know, you go and touch it, then you find that, wow, this is really very hot. Okay, but of course the thing is that you might not know why. Okay, why do I feel it's very hot? The only thing that comes to your mind is that the temperature is very high temperature. So that's the only thing that you remember. But in actual fact, these two, they are related, but they are actually not the same thing. So when we talk about something that is hot, right? Hot, it means to say there is heat. Okay, and this heat will flow to you so that you feel that it's actually hot. Yeah. So, and everything that is of a certain high temperature usually will have heat that can flow to you. So heat is a form of energy, and it's something that can flow to you when you are talking about something of a higher temperature than you. Then on the other hand, temperature, as you can see from here, this is a clinical thermometer, the one that you use in the clinic to measure your body temperature. So the range is pretty limited to only about something close to your body temperature, so about 36.7. But the thing is that, right, when we measure this, then this is the thing that tells us, I would say, accurately, what exactly is hot, your definition of hot. Because hot is something that's very subjective. Maybe you would like to eat BBQ, so you have been dealing with a lot of hot plate and food that could be potentially very hot, very warm. So you're okay with that. But versus a person that likes to use ice cream most of the time, the person that uses ice cream might actually be saying that, maybe 20 degrees Celsius is quite hot, because the food they are dealing with is mostly in the 0 degrees Celsius range, right? So, but in order to be more accurate and less case of dependent on people, right? Then in this case, we will say that we have to measure it. And as a result of that, right, we use this thing called temperature, which is a measure of hotness and coldness. So what is something that is very hot? What is something that is very cold? We don't have to debate. This is 50 degrees Celsius, this is 30 degrees Celsius. 50 is definitely of a higher temperature and it's supposed to be hotter. Okay, a common question that the exam will ask you, like, what is temperature, right? So it's not heat, it's not how much something heat has, but it's more of like the hotness and coldness. So back to the question of how do you know something is hot? And I have actually previously talked about this, because when something is hot, this thing will be of higher temperature. And of course, our hand relative will be lower in temperature. So which means to say that once there's a temperature difference, then heat will start to flow. So this is heat. And because of that, this is the thing that gives you the sensation of it is coming close to something hot. It's in a way a mechanism in our body to tell us that we are looking at something very hot because a lot of energy is flowing into you. So whenever heat flows into you, you feel that the thing is hot. And that can only happen when you're talking about high to low temperature. Okay, heat will flow. Then on the other hand, you feel that something is cold, you might have guessed by now that it means to say heat is flowing away from you. So heat lost by you. So when you lose heat, you will then feel cold. And once again, it's our body mechanism telling us that when we are losing energy, it's a sign of danger. Actually, both ways could be danger. When heat flows to you, maybe you might actually injure yourself because of the heat. And when heat flows away from you, you might be running into the risk of having a very low temperature of your body, then you will fall sick and so on and so forth. Because after all, as a human being, living organism in this world, we have a range of temperature we can work in. And in this case, if let's say if it's too low, then we might actually run into the risk of falling sick. Okay, and of course, apart from that, there are actually many things around us that can help us to feel hot or cold, or hotter or colder. So imagine if let's say your feet is on this carpet, okay, this carpet, and the thing is that you will feel very comfortable when your feet is on the carpet. As compared to when your feet is just on the marble flooring, you will then find that, okay, carpet is more comfortable. And the reason for the sensation of comfortable is because you feel warm. But maybe not so much as a country in Singapore, where every day is very hot, very warm. But however, of course, if you turn on the aircon when in the aircon room, then having the carpet will be something that is good for you because you feel that it's warmer, more comfortable, so on and so forth. And of course, the reason why, you might be wondering, why the carpet actually helps you is because that carpet do this thing called trapping of air. So in this topic of heat and temperature, one of the things that we need to understand about things around us is the idea of conductor of heat. Remember when you're answering a question in the exam, because there's also this thing called the conductor of electricity, so you might want to state very clearly that you're looking at heat, not electricity, if that's really what you meant. And as a result of that, right, when you talk about this, you have to talk about, oh, okay, this is a good conductor of heat, and this is a bad conductor of heat. That's why conductor means pass on, okay? In case you don't know what is the word conductor, means pass on. So something that can pass on heat to you very well will cause you to feel hot very fast. But something that passes on heat to you very slowly will actually means to say that you will feel very colder relative. But in the case of the feet, let's say if your feet is here, right, it's more of the case where we are talking about heat going away from us to the surrounding. So if let's say this carpet traps air, then it will prevent heat from going away from you. So this thing that we are looking at, this arrow I'm drawing here, let's say these are heat, this will not really happen, this will not really happen, this will not really happen. And when I say not really happen, I mean they happen slower, not zero. I think most likely you won't get something that can actually totally cut off heat, but it will just flow slower to the environment. Okay, so when you're explaining this, the thing that makes it happen is not really the carpet, but mainly the air which you are trapping, which helps you to prevent the heat loss to the surrounding. And of course, if you are deciding which container is a better choice, if the thing is because your mommy might have cooked something very yummy, you want to bring to your friend, so you have to put it in a container that is able to keep warm. Then let's say you have a few containers in front of you and you want to decide, do I use the one on the left or do I use the one on the right? So let's say the left one, right, is actually container A and the right one is container B. Let's not assume that we know the material. Okay, let's say we don't know. But you conducted some sort of experiment and this is what you see. So in 1 minute's time or 60 seconds, container A's temperature, right, let's say you put a thermometer inside, it went from 50 to 40 to 30, just in a short span of 1 minute. Then after that, container B, you see that it went from 50 to 40 to 45. So the question is, which one to choose if you want to keep your mommy's food warm? for a longer period of time, so that when you bring to your friend, it is still going to be yummy and not all cold and soggy and so on and so forth. So what do you think? Okay, I believe the answer is pretty obvious, that we will take, okay, B, right? So the reason is because that it is clear from the data given to us, which you need to talk about it. So in a science question, normally they will give you data like this, then you might want to really talk about the data, okay? Use it to support you the claim. So in this case, B is more suitable. Why? Because this is as the temperature of the water is higher at the end of the 60 seconds. So this means to say that it's a poorer conductor of heat and can keep food warm longer. So talk about the data, make your conclusion, and then decide on why you want to use that. So this is a really, really common question in heat and temperature. Okay, and let's talk about some of the application of heat and temperature. You thought I have went to that, but actually I have not yet. Okay, so this very first one is to explain a scenario where, hey, if you pour hot water into a very thick glass cup, the question is, how come when you pour in immediately it will crack? Right? Or maybe not immediately, maybe 10 seconds later. Right? So this is also, there's some very interesting science behind it. Of course, the main thing is, okay, let's look at the cross section of the cup. So imagine the blue color part is the wall of the cup, and the bottom is the black color part. And when you pour in the hot water, do you know that actually this is happening? The inside will gain heat first. And the idea of that is that because when objects gain heat, they will expand. They become bigger. So there will be an outward expansion in this case, trying to push out. But can I do so? It depends on whether the walls outside, which is this one, right, is able to do it together. But unfortunately, no. Because outside will also gain heat, however, compared to the inside is slower. Remember where you pour your water? You pour it inside. You don't pour it outside, right? So outside relatively is actually colder than the inside. So as a result, they will also expand but slower. And that is what that caused the cracking. Because the outside will crack. Actually, the crack part, right, is actually outside. Reason why is because that, right, you are pushing against a wall that is not moving yet. So if you continue to push, you cause it to crack. Okay, so when you pour water inside, especially if the glass is thick, there will be some time needed for you to pass on the heat. And as a result of that, outside will expand later. Okay, so the reason why. And of course, coming to the next part, which you might have seen before as a science question, how come the ink droplet will move to the left or to the right? Of course, the question is, what am I doing to the container? So imagine in this case, right, if I were to heat container A, okay, let's say I heat container A, let's say there's a Bunsen burner, I heat container A, then what will happen? So once again, think about the idea of expansion again. So expansion means you become bigger. And the thing that is inside the container would have been air, right? So as a result of that, if I were to heat air inside the container, then that will push the ink droplet towards B. So meaning to say that, right, because the air push, and in this case, I'm not heating B, I'm heating A. So the air inside A will actually be hotter, and then they will start to expand. Then they will push towards because they need space to expand, they will have to push the ink droplet that is along the way. Yeah. So next time when you are looking at the setup and then after that you see the ink droplet moving in whichever direction, right, then almost immediately you can think of it as the side where the ink droplet is moving is the colder side. Okay, because the ink droplet has been pushed by the air to move to the right. Okay, coming to one of our last slides for today, really about heat again. So if let's say you maybe you want to get a glass of water, but however you find that you have difficulty pulling out the cup. So like this, they are stacked together. So usually we want to save space, we stack them together. And then the question will be, right, I can't do it. So then the next question will be, how do we then separate them? Yeah. So in front of you, you have an option. You have some ice cube, as well as you have a cup of water that is hot. Okay, there's a tub of water that's hot, maybe not a cup. So the question is, what can you do to solve the problem? Okay, so take 1 second, think about it. Okay, is it what you are thinking? as per what we have explained just now? Yes. We will place the cup at the bottom in the hot water. So which means the entire thing I'll put it in hot water. Then while inside the cup, right, the first one, so this one will be in the hot water, like that. Then the top one, right, you throw in some ice cube. And as a result of that, we make use of the principle of expansion and contraction. So in order to separate them, right, you need the cup at the bigger to be bigger. You need the things at the top to be smaller. So you shrink the top and you expand the bottom, and then that is where you get the cup to be separated. Okay, because when you do that, right, expansion will cause the cup to do this, and contraction will cause the cup to do this. So now you created a gap between the cups, and then you will be able to pull out easier. Okay, and that's all for today's video. Okay, it's really just about heat and temperature. Of course, at the same time, while giving you some idea of what are the things that's happening in the real life and how do we overcome them, the main thing is to give you the words, okay, the exact words. Use the correct words to really explain what's going on in your daily life, as well as, of course, finally your questions in the exams. Alright, so I hope you find this video useful. And of course, if you like the video, please help me to like and subscribe and share with the rest of your friends so that more people can be helped. Okay, thank you very much. I'll see you again in the next video.